Alrighty, here today we'll be looking at experimental probability, what it is, how to calculate it, and when it's appropriate to use it. This video is suitable for you if you are in grade 11 or if you're reviewing your experimental probability. This is suitable for a 3C class. The prerequisite skills we're using today, the ability to work down, which is not new to us in this course, and the ability to use some substitution. Again, not new. We used working down and substitution when we were working with our right angle triangles already. Experimental probability is a percentage or a fraction that comes from observing an experiment that can tell you the likelihood of a certain event occurring. Experimental probability, we're looking with a capital P, E for the probability calculated experimentally, which is equal to the number of successful outcomes divided by the total number of trials. Again, this comes from observing an experiment. So this number is coming from how many times you watched the experiment, how many trials you watched the experiment, and the number in our numerator comes from the number of favorable or the number of successful outcomes in terms of the calculations. If you're getting a little bit lazy, we can shorten this. The number of successful outcomes divided by the number of trials, or total trials, if you will. So let's look right here. Pippi rolls a 6-sided die several times and records the data in a table below. So we don't know or Pippi rather does not know at this point whether this die is a fair die or whether it might be weighted a certain way. There might be certain numbers that are more likely to come up. We're not sure, so we're observing, and we're going to use our observations to make some calculations. From all of this data that Pippi observed, we need to take a look and see the total number of rolls. That's nice and easy. We're looking at the number of times that each number was rolled, and we can see the totals down in here. If that's the case, then our total number of rolls is going to come from 2 plus 3 plus 4 plus 3 plus 5 plus 3. That is our total. And that's equal to 20 total rolls, nice and easy. What's the experimental probability of rolling a 3? If right now you think you feel pretty comfortable with this brand new equation that I've given you, try it out. Try pausing the video here and calculating it. But either way, I'm going to go through it here. A good habit to get into when you're performing a calculation like this, always start off by writing out your initial equation again, right? So we're not going to perform any substitution yet. We're going to start off with our equation, and then we're going to build in right here. So our number of successes right here, we're looking at rolling a 3 specifically. So I'm not caring about how many times we rolled a 1 or a 2 or a 4 or a 5 or a 6. I'm just looking at how many times we rolled a 3, and we can see right here that's 4 times. That's my numerator. That's the number of successes. Now the total number of trials is however many times we saw Pippi roll this dice, or Pippi tracked rolling the die, and that is 20 right here, calculated in part A. So 4 over 20. Great job. You have just calculated your first experimental probability. Can we reduce this fraction? 4 over 20, absolutely. We can divide the numerator and the denominator each by 4. We'll end up with 1 out of 5. That means for every 5 rolls, Pippi rolled her dice. She expected, or she observed, rolling a 3 for 1 time. We would expect to roll a 3 every 5 times that we roll the dice on average, if this pattern is to continue. Now, that's all well and great, but you might prefer to have your answer as a percentage, so we can throw this into our calculator, 1 divided by 5, and then we multiply that times 100%, and we end up with 20%. Nice work. Either of these final answers is acceptable right here. Either giving your final answer as a percentage or giving your final answer as a fraction. Either is acceptable. Now, again, I encourage you, try and pause the video here before trying out part C. If you feel like you can handle it, jump right in. You've already seen us perform a calculation once. See how you do. We're working right here again. So we're looking at a percentage of the rolls resulted in the die showing less than a 3. What they're really describing there is an experimental probability. So we'll jump in. We have our experimental probability is equal to the number of successes divided by the total trials. Now our key in this case is given by the descriptor, again, showing less than a 3. So let's go through it nice and quickly. A 1, is that less than a 3? Absolutely. A 2, is that less than a 3? Absolutely. A 3, is that less than a 3? No, it's not. It's equal to, it's not less than a 3, so we're not going to care about that. A 4, no, it's not. A 5, a 6 are not. So our main focus right here, these are what describe to us, or what tell us how many successful outcomes we saw. And that is, we had 2 plus 3 successful outcomes. If you write down a 5 right there, that's completely fine. I'm going to write it out like this so that I'm showing all my work. How many total rolls were there? There were still 20 total rolls. And so we're working with 5 over 20. Can we reduce this fraction? Absolutely, yes, we can. We can divide the numerator by 5, divide the denominator by 5. We end up with 1 over 4. This, again, is a fully acceptable final answer. If you prefer to give your final answer as a percentage, you'll be working with 1 divided by 4 times 100%. We're working with 25%. If you're comfortable here, we're going to take a look. We're going to consider when we use this. We don't use this if we completely understand a system, what's going on. If we have a fair coin, if we have a fair die, that is a coin that we know flips 50% of the time to heads, 50% of the time to tails. If we have a fair system that we completely understand, we're not going to use experimental probability. We'll talk about what we use later. But if we have a system that we don't fully understand, and that might be if we have a die that we're not sure whether it's fair or not, if we have say a closed bag of items, of tokens, and we're pulling one out of a time, but we're not sure how many of everything is inside that bag, we would use experimental probability to make predictions. If we have something very complicated that comes from many, many different factors, something like the weather, we would use experimental probability to observe what the weather has done at certain times in a year at a certain location, and we would use that information to make predictions for the future. So in this case, we have used experimental probability to gain a bit of an understanding for how we calculate it, and we would do this if we don't necessarily know that this die is fair. I'm hoping, if you were able to follow along with this lesson, I'm hoping you feel comfortable with our equation. I'm hoping you feel comfortable recognizing the equation, substituting into the equation, and coming up with a reduced fraction or a percentage for your experimental probability. Nice work.